Of the 6 trig integrals, we only know how to do 2. Have y'all realized that? We know 6 trig integrals, but they're not the 6 basic ones. We only know how to integrate plane sine and plane cosine. We do not know how to integrate plane secant, plane cosecant, plane tangent, or plane cotangent. We know how to integrate secant squared, right, and secant tangent. We do not, up to this point, know how to integrate tangent. However, the quotient identity tells us that tangent of x is the same as sine over cosine. So what I could do is I could rewrite tangent as sine of x over cosine of x with respect to x. And then I could bring the bottom up to the top. And then you find out what
do you get rid of?
Derivative.
Well, who do you get rid
cosine
of?
is-
Get rid of the one that doesn't have the negative 1 attached to it.
So you say whose derivative is cosine?
Right, so we keep him
You need a negative.
and we give away his derivative. What's the derivative of cosine?
Negative.
Negative sign. So I'm going to keep this guy, and I'm going to give away a negative sine of x dx. And I have the sine x and I have the dx. So since I had to make up the negative, I can balance it with a negative 1 outside.
Okay.
Right? This sacrifice turns it into a power rule problem, not a trig problem. Anytime you sacrifice the derivative of the inside, it makes it a power rule problem. However, when that power is a negative 1, it's going to integrate up to the natural log. So we really have the negative natural log of the absolute value of cosine of x plus c. That, if you would like to memorize it, is the integral of tangent. I don't think you should have to memorize it because I think you should probably be able to do that each time. And then, of course, we could check it. We could check it by saying we have a negative. We take the derivative of the blah, which is negative sine, and divide by the blah. And a negative negative makes a positive, and a sine over a cosine makes a tangent. Yeah. This is pretty cool. How about you guys try the integral of cotangent? You guys try to do the integral of cotangent of x dx. Hey, and on your last quiz, a lot of you mixed up. You thought tangent was cosine over sine. Be careful. Cotangent is cosine over
I
sine.
plugged that in my calculator. Yeah, that's
Something
what.
natural log or something.
Yeah. Okay. What'd you guys write this one as? Cosine over sine. Bring the sine to the top. So what's the derivative of the inside of this? Cosine x dx. Hey, what a coincidence. Look at that. That's what I have. So that means that this integrates to the natural log of the absolute value of sine x plus c. So you don't really have to memorize tangent and cotangent. You can use your quotient identities to figure those out if you ever need to. But there are two that are very difficult to just figure out, because to integrate secant and cosecant requires you to just make something up out of thin air, like a conjugate, when there's really not a binomial there. And so it really freaks everyone out. So the best thing you can do for secant and cosecant is just to memorize them. But as far as the others go, we already know sine and cosine, right? The integral of sine would be negative cosine, and the integral of cosine would be sine. We just learned tangent and cotangent. These, you could use the quotient identities. So you don't really have to memorize them. But these two, and I'll be happy to show you if you'd like where they come from, they're a lot harder to just figure out, you know, if you write them. So the best thing you could do for these is to just memorize them. So the integral of secant is the natural log of secant plus tangent with absolute value, and the integral of cosecant is the negative natural log of cosecant plus cotangent. And guys, the way to figure out which ones have the negatives, if the answer is a cosine, there has to be a negative. If the answer starts with a C, there has to be a negative. So see, this answer started with a C, and it has a negative. This one didn't, and it's positive. This one starts with a C, and it's negative. This one doesn't, and it's positive. This one, right here, does not start with a C, so it's a positive answer. But this one is a C, so it's a negative. That kind of helps me keep them straight.
Goes yes.
Notice that these are, the problem set for this is 1 through 24 all and 29 through 32 all, plus 47 and 51. They go very, very quickly, but if, remember on Calc Chat in the back of your book, the answers aren't there for the evens, so if you need to jot those down out of the solutions manual or take pictures of it, you may do that.
1 through 22
These-
or 1 through 24?
1 through,
Yeah.
good question.
On our syllabus it says 22.
Well, you can do whatever's on your syllabus. How's that sound? Okay. So you can do whatever's on your syllabus. But guys, be sure that you do this. They're due Tuesday. And be ready for a quiz on Tuesday, because on Friday we'll be doing something different. But I will have time to take questions before the quiz. I know you're excited.